Now we are going to discuss about the continuation of the last video. In the last session, what we discussion related to the projectile motion, maximum height, time of flight, and as well as range. So now we start where we are ends in the last. So we are taking a relation between maximum height and as well as range. A relation between maximum height and range, maximum height and range. So generally we know that the range is a maximum height. H max is equal to u square sin square theta by 2g. H max is equal to u square sin square theta by 2g. And also the range r is equal to u square sin 2 theta by g. U square sin 2 theta by g. So these two equations looking like similar but not. So whenever you are finding any confusion, just to put theta is equal to 90. Theta is equal to 90 if you are taking sin 90 1 and it's going to sin 180 0. Theta is equal to 90 means you are projecting the body with an angle 90 degrees. That's the means. So now take the ratio of the both. For my convenience, I am taking the ratio of the both. H max upon r is equal to H max u square sin square theta by 2g divided by g upon u square sin 2 theta. 2 sin theta cos theta. Sin 2 theta means 2 sin theta cos theta. Sin theta cancelled. And u square cancelled, g also cancelled. Then what is the remaining? H max upon r is equal to H max upon r is equal to sin by cos tan theta by 4. What is the relation with H max by r is equal to tan theta by 4. For a maximum value of the theta is equal to 45 if you are taking, then you can get H max upon r is equal to 1 by 4. Then H max is equal to r by 4. When theta is equal to 90, then maximum height is 1/4 of its range. There is a chance to ask the question here. So the maximum height is 1/4 of its range. 1/4 of its range. And also we know the relation between time and as well as range. Time of flight and as well as range. What is the relation with the time of flight and range? We know that r is equal to u cos theta into t. No need to take anything. We will take the relation between H max and as well as the time. Relation between H max, maximum height and as well as a time of flight. Maximum height and time of flight. What is the relation? There we are taking H max is equal to u square sin square theta by 2g and time of flight is equal to 2u sin theta by g. 2u sin theta by g. To do anything, just you can take the squaring on both sides. So nothing but t square is equal to 4u square sin square theta upon g square. 4u square sin square theta upon g square. Then take the ratio of both. H max upon t square is equal to H max upon t square is equal to, just take this value, u square sin square theta by 2g into upon t square means that is going to be reverse here, g square upon 4u square sin square theta. G square upon 4u square sin square theta. U square sin square theta gets cancelled. G also. So then H max upon t square means that is going to be 1 by 8g t square. 1 by 8g t square. What is this? The relation between maximum height to the time of. So let's see here, we are projecting two bodies with complementary angles. The projecting two bodies with complementary angles. What are complementary angles? Complementary angles means sum of the two angles is 90. Sum of the two angles is 90. So that angles are said to be complementary angles. For example, 30 and 60 are complementary angles. 45, 45 complementary angles. 15, 75 complementary angles. So the sum of the two angles is called complementary angles. Here I am projecting two bodies with the complementary angles. One is theta and other angle is 90 minus theta, and other angle is 90 minus theta. Theta 1 is equal to theta 2 is equal to 90 minus theta. So these are named as complementary angles. For the complementary angles, what happened to the range, maximum height and as well as time of flight? Let's have a look. So this is the first object and this is the second object. Two objects are projecting with complementary angles. Complementary angles. Two bodies are projecting with complementary angles. Complementary angles 1 and as well as 2. So first I am taking the range of the first one. R1 is equal to u square sine 2 theta by g. No doubt in that. Next, range of the second one, u square sine 2 of 90 minus theta. Sine 2 of 90 minus theta, because angle is 90 minus theta upon g. Then range is goes to u square sine of 180 minus 2 theta. Sine 180 minus theta is sine theta only. The range R2 is equal to what we are getting, u square sine 2 theta by g. U square sine 2 theta by g means nothing but if two bodies are projecting with complementary angles, the range of the bodies are equal. If two bodies are projecting with complementary angles, the ranges are equal. The ranges we are taken as R1 is equal to R2. When two bodies are projecting with complementary angles, the ranges are equal. R1 is equal to R2. Then what about their maximum heights? What about their maximum heights? And what about their time of flights? That's also we'll see. First, you can take maximum height. Maximum height of the first one, this one, h1. And this is the maximum height of the second one. Maximum height of the first one, h1 is equal to u square sine square theta by g. No doubt in that. U square sine square theta by g. Next, second one, sorry, 2g. Next, second one, u square sine of 90 minus theta. Sine square 90 minus theta. Sine of 90 minus theta, cos theta. Then h2 is equal to u square cos square theta upon 2g. H is equal to u square cos square theta upon 2g. Means nothing but maximum height is different. Maximum height is different. So let's what we will do. Just you can add both for our convenience. Just add what will happen. Let's see. H1 plus H2 is equal to. H1 plus H2 is equal to what is the value? U square sine square theta by 2g plus u square cos square theta upon 2g. I am taking u square by g common. Then sine square theta plus cos square theta, that is equal to 1. Then h1 plus h2 is equal to simply u square by 2g. Means the maximum sum of the maximum heights of the two bodies are projecting with complementary angles, that is equal to u square by 2g. Sum of the maximum heights of the two bodies are projecting with complementary angles. The value is u square upon 2g. The value is u square upon 2g. Let's see time of flights also. Time of flight of the first one, t1 is equal to 2u sine theta by g. Time of flight of the first one, 2u sine theta by g. Time of flight of the second one, 2u sine of 90 minus theta. Sine 90 minus theta, cos theta. T2 equal to how much you are taking? 2u cos theta by g. 2u cos theta by g. T1 time of flight of first projectile, T2 time of flight of second projectile, R1 range of the first projectile, R2 range of the second projectile, H1 maximum height of the first projectile, H2 maximum height of the second projectile. Now is there any relation we can able to get from T1 T2 to the R? Let's multiply T1 and T2. If you are multiplying T1 and T2, how much you are getting? See here, 2 into 2, so keep like that, 2u square is you can able to write 2u square into 2 sin theta cos theta, 2u square into 2 sin theta cos theta upon g square we can able to take now. See here, 2u into u, 2u square, 2 sin theta cos theta, because I can able to get sin square cos square theta means 2 sin theta cos theta means sin 2 theta I can able to get. Then the value of T1 T2 is equal to how much you can able to get, 2u square sin 2 theta upon g. Sin u square sin 2 theta upon g is nothing but u square sin 2 theta upon g. U square sin 2 theta upon g is nothing but range R. So then T1 into T2 is equal to 2g into R. 2g into R. So that is the range, and finally what you can able to write there, R is equal to g by 2 into T1 T2, g by 2 into T1 T2. So this is the relation between complementary angles of the two bodies. If two bodies are projecting with complementary angles means sum of the two angles is equal to 90. One body with an angle theta and other one is 90 minus theta. Then R1 is equal to u square sin 2 theta by g. That you are getting this much. Sin 180 minus theta, sin theta only. Cos 90 minus theta, sin 90 minus theta, cos theta. Sin 90 minus theta, cos theta. So like that we can able to get. And last in this only, for the range only, we will take one more expression of that. We know the equation of the projectile. That is y is equal to tan theta x minus gx square upon 2u square cos square theta, gx square upon 2u square cos square theta. Multiply and divide with the sine function. This is multiply and divide with sine function. Sin theta upon sin theta, sin theta upon sin theta. So just you can get y is equal to tan theta x minus g upon 2u square into one sine you can write here 2 sin theta cos theta into sin theta upon cos theta. Means what I did here, nothing. This cos square I am writing cos theta into cos theta, and this sine function I am writing here. That's all. Now see what will happen. Then y is equal to tan theta x minus here x gx square upon u square into sin 2 theta cos theta, sin 2 theta into 2 sin theta cos theta, sin 2 theta into tan theta. Now see here, this is u square sin 2 theta by g. U square sin 2 theta by g is nothing but r. Just put the value of r. Then y is equal to tan theta x minus x square tan theta upon r. This total value is r into tan theta. Now what you can able to take common? You can able to take common tan theta into x if you are taking common. Then 1 minus x upon r. So this equation also represent projectile motion equation. So just you can focus and practice, then automatically you will get it.